We're talking now about exponential inequalities. We love these. We're going to start out the same way. I'm going to divide this not at the equal, but at the inequality. I'm going to set up my graphs. And you'll notice, yes, these are the same numbers as we worked on the last equations, but the difference is I have an inequality this time. So I'm going to graph the same example here. I'm looking at the graph. I have a solution at the point 39, but remember, an inequality is not just a point as a solution, it's a whole region. So I have to decide, in this case, a little different from rationals. In the rationals, we needed this, and in between that and the vertical asymptote. For this, I only needed the point right here, but I do need to know, is it going this way, which would be everything numbers less than 3, 0 is less than 3, or is it going this way, which would be everything greater than 3? So there's a few ways I can check. One is my table, and I can look right here and I can say first function should be less than second function. And let's just look where that's true. Starting this direction, which would be less than 3, is my first function. My value is 1, less than my second function. The value is 9. Well, 1 is less than 9, so this is true. Where if I went this way, greater than, 81 is not less than 9, so this is false. Which means that my solution is everything less than, all these numbers that are less than 3. So from this I would say x needs to be less than, I don't want an equal here because I didn't have one here, less than 3. I can also think of it on the graph as less than means below. Where is the exponential function below the line? From this point here over, it's below. Here's my exponential, here's my line down below. After that point, it's above. So this section is true, this section is false. So for this one also, I would say x is less than 3. Now Mr. Bell is going to come show us an alternate method to use on your graph here.
Alternate method is to graph it all in one shot. In that case, everything has to be to the right side of the inequality sign. So therefore, this has to go over here. In order to move that over there, we need to subtract it from both sides. So this becomes, and you can call this whatever you want to, y or f of x or whatever, but it's 3 squared, and then of course we subtracted this from both sides to get it over here. So it's 3 to the 2x minus 4. And this is what we're going to be graphing on the calculator. Of course, this will end up looking like a y when we get finished. So let's go to the calculator and graph that. So right here, we're going to back this up so that we have our inequality. We wanted less than, and of course it was 3 squared minus 3, 2x, what was that? I forgot. 2x minus 4. So we entered it into the calculator correctly, and we have this situation. Thing we have to make certain of, though, is we have, first of all, we find our boundary, because we have to see what the boundary is for sure. If it's a dotted line or a solid line. Of course, the hint was given in the equation, but still, if this is a dotted line, then we will have an open circle where the shading starts with the x-axis. It's all about where does the x-axis go through the shading. Where does the x-axis go through the shading? Well, it starts right here, which means that it's not equal to, so it's, and it goes in this direction. That direction is less than. If it was going the other direction, it would be greater than. So what's this point? It's 3, so we know that x is less than 3 because it is pointing to the left. It's all about where is the x-axis as it goes through the shading.
All right, let's look at a second example. We're going to do the same thing. I have 2 raised to the 3x plus 6, this is on your handout, greater than or equal to 8. f1 of x is everything on the left-hand side. f2 of x is everything on the right-hand side. I'm going to graph these two functions and I want the intersection. So let's graph here. So I have 2 raised up to the 3x plus 6, enter, tab, and that is 8, second one. Again, off my screen, zoom out a little bit till it's in the screen. And this is just like the last one we did. We know that that intersection is at -1,8. So I'm bringing up my table here. Now we know that this is the intersection, but this is an inequality, so I'm not just looking at this number. I want to know, is it everything less than this or is it everything greater than this? So my equation said that I need f1 of x to be greater than or equal to f2 of x. So I look right here above. Is 1 greater than or equal to 8? That's false. Is 64 greater than or equal to 8? That's true. So what I want is everything greater than or equal to -1 here. Let's look back at our graph. If I think of above and below, greater than means where is the exponential above my line here? Well, all along this, remember we're reading the x-axis. Up until right here where x is -1, it's below. So I can't include this section. Starting at -1, it jumps up above. So from here on, that's my solution. So again, x is greater than or equal to -1. Now let's do the inequality again. And add a graph page in.
Same idea, we're talking about where does the x-axis go through the shaded area. Okay, thank you. So we have our original equation, or actually our original inequality. Like this, means this part here has to move over to the right side. So we have greater than or equal to 8 minus 2 to the 3x plus 6. This is what we'll be putting into the graph page. Of course, we have to erase that in order to put it into here. So here we have, back it up so we get our inequality. It is greater than or equal to, we have 8 minus 2 exponent 3x plus 6. We graph it. There it is. Again, we have to make sure, we have to find out what our line is, and by touching on it, we can see that it is indeed a solid line. If I get my little arrow off there, it is a solid line. Therefore, we know that it's included, if we didn't know that already, and it is greater than. It is going to the right. It's all about where the x-axis goes through the shaded area. So we know that it starts right there at -1. So x is greater than, solid circle, or equal to, -1.